Welcome back to Supreme Auto Elite, the broken promise of modern cars. For decades, American cars symbolized freedom, power, and reliability. From the unstoppable Ford Crown Victoria, to the indestructible Chevrolet Silverado, to the legendary simplicity of old Honda and Toyota models built on American soil. Cars used to be machines you trusted. You bought one, you drove it, you changed the oil, and it lasted 15, 20, sometimes 30 years. But today, something has changed. New American cars are faster, more comfortable, more fuel efficient, and packed with technology. Yet owners complain more than ever. Electrical failures, transmission breakdowns, engine recalls, software glitches, infotainment systems freezing, expensive repairs before 100,000 miles. This raises a difficult question. Why are new American cars so unreliable, despite all this technology and progress? The answer is not simple. It is not one mistake. It is the result of decades of decisions, economic pressure, corporate priorities, and modern consumer expectations. Let's break it down. Chapter 1: What unreliable really means today. Before blaming manufacturers, we must redefine the word unreliable. In the past, unreliability meant engine failure, transmission failure, rusted frames, mechanical breakdowns. Today, unreliability often means sensors failing, software crashes, warning lights with no real issue, infotainment systems not working, electrical gremlins, expensive electronic repairs. Modern cars may still drive, but they fail to function correctly. A car that randomly disables safety systems, goes into limp mode due to a faulty sensor, refuses to start because of a software error, is still unreliable, even if the engine itself is fine. And American cars, more than ever, suffer from this kind of unreliability. Chapter 2: Too much technology, too fast. Modern American cars are rolling computers. A typical new vehicle now contains 50 to 100 electronic control units ECUs, millions of lines of software code, dozens of sensors, advanced driver assistance systems, over-the-air update capability. This is more software than early spacecraft. The problem: automakers are not software companies. Detroit's expertise was mechanical engineering, not coding. When companies rushed to compete with Tesla, they added massive touchscreens, integrated complex infotainment systems, introduced semi-autonomous features, connected everything to the internet. But this technology was often poorly tested, rushed to market, incompatible across systems. A single glitch can disable power steering, braking assistance, engine management, climate control. Old cars failed slowly, new cars fail instantly and expensively. Chapter 3: Planned obsolescence in the auto industry. One uncomfortable truth: modern cars are not designed to last as long as older ones. Manufacturers today prioritize lease cycles 3 to 5 years, warranty periods, subscription services, repeat buyers, not long-term durability. Engines are now smaller, turbocharged, high stress, operating under extreme heat and pressure. Transmissions have 8, 9, even 10 gears. Complex hydraulic and electronic systems. These designs improve fuel economy, emissions compliance, performance numbers, but they reduce mechanical simplicity, long-term reliability. When a turbo fails at 80,000 miles, the repair cost can exceed the car's value. This is not accidental. It keeps customers buying new cars instead of maintaining old ones. Chapter 4: Cost-cutting and cheaper materials. Modern American automakers operate under extreme financial pressure. Shareholders want higher profits, lower production costs, faster development cycles. As a result, plastic replaces metal, thinner components replace thicker ones. Suppliers are forced to cut corners. Examples include plastic intake manifolds cracking, cheap wiring insulation degrading, low-quality sensors failing prematurely. The car may look premium, but underneath, it's built to a price. Even luxury American brands are not immune. Chapter 5: Complex engines and emissions regulations. Government emissions regulations play a major role. To meet fuel economy and emissions targets, automakers use direct injection, turbocharging, cylinder deactivation, start-stop systems, exhaust gas recirculation (EGR), particulate filters. Each system adds complexity, failure points, maintenance costs. Cylinder deactivation systems in American version 8s, for example, have caused oil consumption issues, camshaft failures, lifters collapsing. These engines are powerful, but fragile. Old engines were inefficient but durable. New engines are efficient but stressed. Chapter 6 Transmissions. More gears, more problems. Older automatic transmissions had 3 or 4 gears, simple hydraulics, proven designs. Today's American transmissions, 8 to 10 speeds, electronic shifting logic, adaptive learning software. While impressive on paper, they often suffer from harsh shifting, delayed engagement, software confusion, premature wear. Some modern transmissions hunt for gears constantly, increasing wear. When they fail, repairs cost thousands. Chapter 7 Supplier Dependency and Global Parts. American automakers no longer build everything in-house. They rely on global suppliers, outsourced electronics, shared platforms. A single supplier defect can affect millions of vehicles, entire model years. When quality control fails, recalls explode. This system saves money, but reduces accountability. Chapter 8 Dealership Diagnosis Problems. Modern cars are so complex that even dealerships struggle. Technicians rely on scan tools, follow software prompts, replace parts instead of diagnosing root causes. This leads to misdiagnosis, repeat repairs, customer frustration. A simple wiring issue can become a $3,000 repair. Chapter 9 Shorter Testing and Development Cycles. Older cars were tested for years before release. Modern cars are rushed to market, updated via software later, treated like smartphones. Manufacturers fix problems after customers discover them. The buyer becomes the beta tester. Chapter 10 Comparison with Japanese and Korean cars. Japanese automakers emphasize conservative engineering, long testing cycles, fewer and proven technologies. Korean brands focus on simplicity, long warranties, value over innovation. American brands often chase features, performance numbers, market trends. This philosophical difference matters. Chapter 11 The Electric Vehicle Transition. EVs introduce new reliability concerns. Battery degradation, software dependence, charging system failures. Traditional automakers are still learning. Tesla exposed the industry's weaknesses. Legacy American brands are catching up, but mistakes are inevitable. Chapter 12 Consumer Behavior contributes to consumers' demand. More features, bigger screens, faster acceleration, better fuel economy, all at lower prices. This forces compromises. You can't have maximum reliability, maximum technology, maximum performance, minimum cost. Something has to give. Chapter 13 Are all new American cars unreliable? No. Some models are well engineered, proven, relatively dependable, but consistency is lacking. Reliability varies dramatically between models, engines, production years. Research matters more than ever. Chapter 14 The Future. Will it get better? The future may bring simpler EV drivetrains, fewer moving parts, improved software maturity, but also subscription features, locked repairs, proprietary systems. Reliability may improve mechanically, but worsen digitally. Conclusion. The real truth. New American cars are not unreliable because engineers are incompetent. They're unreliable because cars became computers, profits trump longevity, regulations increased complexity, consumers demand everything at once. Reliability is no longer the primary goal. And until priorities change, unreliability will remain part of the modern American automotive experience.